Okay guys, let's take a look at today's lesson. Today we're going to be looking at absolute value. We're going to spend some time on this topic. It's pretty important that we understand how to translate things out of absolute value for a number of different reasons. First of all, we can't really work with absolute value. Like I can't take the derivative of just absolute value x. I can't really do that. I have to translate it into this piecewise function before I can do that. I can't do an integral. I mean, you know from previous experience, when you have an absolute value equation, you have to solve two equations, where we just really typically have two or more of everything when we have an absolute value. So we need to learn how to translate it out of absolute value. This is the definition of absolute value. This is the definition. And in the definition, notice how the top piece is x when x is larger than or equal to. Notice where they put the equal part, right? That's usually a confusion for students. How do I know where to put the equal part? Well, in the definition, they put it with the top piece, with the bigger piece. X is bigger than or equal to 0. And then the negative x is where x is smaller than 0. We will have other, a wide variety of different types of absolute value functions we're working with, and this is just the basis of them. So there are also some properties that we need to understand. We're actually not going to use these properties directly in this lesson, but they're just things that we need to know that are possible for future work with absolute value. We certainly know that the absolute value of negative x is going to be equivalent to the absolute value of x. Those would kind of think about that and numerically. It is also possible, if I have the absolute value of a product of two functions, I am allowed to split them apart into separate absolute values. This kind of technique would help us later in simplification. Likewise, when I have the absolute value of a whole fraction, I can split that to the absolute value of the numerator over the absolute value of denominator. And this is just an identity kind of property thing that they call the triangle inequality. We're not really going to be using it, but this is just the scenario. If I have a sum of two things inside of the big absolute value, and I break them apart into two separate absolute values, the addition of two separate absolute values, this side is going to be larger than that side. And again, we're not going to use that in that lesson. In this lesson, it's just some information that would be good if we were familiar with it. What we're going to be doing today is we're going to be rewriting absolute value as piecewise, and these are the general guidelines or steps that we're going to use when we do this. The first thing that we're going to want to do is we're going to want to set the expression inside the absolute value equal to 0 and solve it. This is where our piecewise function will split. That's how these numbers over here are created. The inside of this, x, set that equal to 0, x is 0. Well, that would set it to 0, right? That's why I have a 0 here. And so that's what we will do to find where the piecewise function splits, is we're going to do this first step. Once we do find where it splits, we've got to put those values on a number line and do sign analysis. We need to figure out what's going on. The last step would be the intervals where the expression is negative are written in the piecewise as opposite of the original. So I do want to do just a little bit, I just want to talk a little bit more about the piecewise. So graphically, I want you to think about it graphically. Let's say that we want to do, absolute value of x squared, let's say minus 4. Okay. So if I were just doing x squared minus 4, I would go down 4, right, and I would graph it. I mean, that would just be straight up x squared minus 4. When I'm doing absolute value, what that means is I'm going to be taking this bottom portion, and I'm not allowed to be negative, right? This tells me that all the y values are positive. So if I were to go through our process, we set equal to 0, we get x is going to be plus or minus 2. We do a sign chart. We discover these are our signs. We discover the center part is negative. That's what this looks like. The center part is negative. It's underneath the x-axis. So when we fix the piecewise function, it's going to graph properly. The proper graph of the absolute value of x squared minus 4 would look something like this, with that middle piece would be flipped up, right? It wouldn't be down. So this is visually what we're doing when we manually adjust the center part, is we force it to be, where it's not. If it's negative, we force it to flip up and be positive. Okay. Okay, that's what we're going to be doing when we rewrite these. Questions so far? Okay, let's go ahead and go to the next page. There are a few examples that I want to go through. Really, one of each type that you're going to encounter. There are 3 kinds of problems that you're going to be working with. The first kind is just everything is in the absolute value. Everything in there. That's the first kind of problem. And I think this is the easiest kind of problem, when everything is inside the absolute value. The second type that we will work with is when we have an absolute value plus some other stuff that's not absolute value. They're a little bit more complex, but again, it's not too bad. I think the most difficult kind is this last one, where we have 2 different absolute values that we're either adding or subtracting, 2 or 3 different absolute values that we're adding or subtracting. This is the most complex type, and we're going to look at each of the 3. These are the 3 types you're going to see, one of these 3 things. So let's start with the first type. The first type is all of it's in the absolute value. So what we want to do is we want to think about our procedure from the previous page. Our first step would be to take the stuff inside and set it equal to 0 and find out when that's true. So if I have 3x squared minus 8x plus 4, I need to find out when or if it's 0. So that involves factoring. And so this factored is 3x minus 2 times x minus 2. Okay, so here's where I have my sign chart, my sign analysis chart. So the number that would make this 0, and if you want to keep working it algebraically, you can, or you can do it in your head. 3x minus 2 equals 0, so I move the 2 over and I get, what, 2/3. So 2/3 is one value that makes this 0. The other value would be 2. So what my job is now is to do sign analysis, and I typically like to use the factored portion. You don't have to. You could use the original portion, of course, without the absolute value bars, just the inside part. So if I put a 0 in there, what do I get? I put a 0, I get a positive. I put, say, a 1 in here, and that would give me a negative. And then I put a 3 in, that would give me a positive. So those are my signs, and that tells me how I'm going to have to form my piecewise function. Alright, so we say f of x equals. So in this case, we're going to have 3 different pieces, because that's the number of sections we have on our sign analysis chart. I have this piece, 1, 2, 3 pieces. Just like the definition of absolute value, remember how that started with the biggest x values? That's what we should do. We should model our piecewise functions after the definition of piecewise. And that starts with the biggest x values. That's what we should do. So we're going to start with this piece first. This piece is positive, so I'm going to write in just what I had, 3x squared minus 8x plus 4. And this piece is good from 2 and greater. So x is greater than or equal to 2. And I'm putting the equal sign with this because that's the way the definition does. Or the definition puts the equal sign with the biggest part. So that's what we're going to do. We're just going to model what it does. The middle section is opposite. And I encourage you just to do opposite and then write the original one down. If you feel compelled to distribute, you can. But again, if you distribute incorrectly, then you'd lose some points. So you might as well just leave it like that, just opposite of what we started with. And that piece is good between 2/3 and 2. Now what I like to do, just to keep things straight, is the first time the number appears, like 2/3, that's what I'm going to put the equal sign with it. Do you have to do that? No. I just want a procedure so that I don't accidentally put the equal sign in more than one place with the number, because that, of course, would not be a function, and that would not be okay. So I'm going to do, so it's 2/3, I'm going to put the equal there, less than equal to x, less than 2. So that's where the middle piece is good for. It's good between 2/3 and 2, and again, I'm putting the extra equal sign with the 2/3 because that's when I first saw it. Again, I don't have to, I just want a procedure for myself so I don't get messed up. Then the last piece is it's positive, so we just write it regular, 3x squared minus 8x plus 4, and this piece is good from 2/3 down. So x is smaller than 2/3. And again, I can't put an equal sign under here because I already used it on the 2/3. I can't use it on the 2/3 twice. And so that's my piecewise function, and that's the answer. Okay? Is that okay? All right, let's look at our next one. The next type is where we have a mixture of absolute value and other stuff. You know, absolute value and other stuff. So what I would encourage you to do is write it like this. So f of x equals, I'm going to take my piecewise function. That's actually the definition. So that one we should memorize, or maybe you already have it memorized. It's x when x is greater than or equal to 0, and negative x when x is smaller than 0. Okay, we're going to do that, and then we're going to add to that 3x plus 1. So what this means for us is we're going to take this 3x plus 1 and we're going to add it to each piece, however many pieces there are. And then that's going to be our function. I mean, we're done. So it's not too bad. It's just a little bit different, just a little bit weird. We do this first part, get it all split apart, and then just add whatever we have, you know, or subtract whatever happens over here to each piece. So f of x is going to equal, so I have x plus 3x plus 1 is 4x plus 1. And then I keep my x is greater than or equal to 0. And then I have negative x plus 3x plus 1. See, negative x plus 3x is what? 2x plus 1 is good when x is less than 0. And that's my piecewise function. Okay, am I going too fast? Everybody okay? Yes. Mm-hmm. Exactly. That's exactly right. If this were something more complex, like a quadratic or something, we would just have to go through this step first. You know, we'd have to get it written out like this, and then plus, you know, the 3x plus 1, and distribute that to each of the pieces. Yeah. So yeah, these can get pretty complicated, but the procedure is the same. The process is the same, depending on what kind you have. Okay. Anything else so far? All right, this last one is the most complex one because it involves adding two different absolute values together. But I'm going to take you through the process. It's the way that I'm going to show you isn't too bad. So what we want to do is we want to break it apart. And so this piece, the absolute value of x is x negative x. X is greater than or equal to 0. X is less than 0. Plus. And then we split the other piece up. This other piece is split at 1, right? And if we want to do, you can do the sign analysis in your head, or you can write it out. So this piece right here, we're working on this one. It's split at 1. So if I put a 0 in there, I get negative. So it's split like that. Okay, so let's write this piecewise. So that would be just, we start with the biggest part because that's how the definition does. We just follow that. You know, follow that logic. So we've got x minus 1 when x is greater than or equal to 1, and opposite of x minus 1 when x is less than 1. Now, I encourage you to do this next step. My students that like to conserve energy really don't like doing this next step, but I promise you if you do it, you are less likely to make a mistake. And so what I like to do is I'm going to do a number line. And I'm going to do, on the number line is 0 and 1 because these are the where we're split here. And in each piece, I'm going to write down the function that belongs in each piece. That's just going to make our life simpler. So let's just start with the biggest piece right here. Why not? Let's start over here. When we need to look at, if we look at this, which of the pieces belongs when x is bigger than 1? That would be the top piece, right? That's where x is bigger than 0, so certainly bigger than 1 works. And on this section, x is bigger than 1 with the x minus 1. And I'm just going to write those there. Okay? Because I'm going to add them together. If this was subtraction, then I would need to pay attention to which came first, and I would need to subtract them. Okay? Because there are some with subtraction signs. So if this were subtraction, I would want to put this one, I would want to be a little bit more specific about how I ordered these. Since it's addition, I was just kind of, woo, it's addition. If it was subtraction, I would want to put this one on top and this one underneath so I would know that I would subtract the two. And I'd make myself a note, subtract. Okay, but we're adding. So now I want to find the portions that go between 0 and 1. So I go back over here. So I have to figure out, is the top piece or the bottom piece good between 0 and 1? And it would be the top piece is good between 0 and 1, right? Because this is when x is bigger than 0, so the top piece. Now I go over here. Which of these pieces belongs between 0 and 1? Let's see, this is x is less than 1, so it's going to be this piece, the opposite of x minus 1. Belongs between 0 and 1. Do you see what I'm doing? How I am lining those out? I'm separating them out so that I know which belongs to which section. So the last section is smaller than 0. So I again go over here to the first one. Which of these pieces belongs in the section smaller than 0? That would be the negative x. And then which of these pieces belongs smaller than 0? That would be the negative, the opposite of x minus 1. So I'm going to pause there for a second. Do we all understand how and why I pulled those out? Because what's going to happen is this is going to add to be the section belong here, you know, the function that belongs here. These are going to add together to be the function that belongs between 0 and 1, and these are going to add together to be the function that's greater than 1. So I've just laid my work out right there so I can see what I'm supposed to do. So now I have f of x equals, and I'm going to start with this where x is the largest because that's the way the definition does. So I add these together. So x plus x is 2x. So I have 2x minus 1, and that piece belongs from 1 to infinity. So when x is greater than or equal to 1. And of course I'm putting the equal sign with this first piece because that's what the definition does. I hope you see the logic on why we're doing what we're doing. The next piece is this in here. So I have x minus x, so the x goes away, and then I have a minus minus x, which would be 1, or excuse me, a minus minus 1, which is a positive 1, and it's positive 1 between 0 and 1. So 0 less than or equal to x less than 1. Again, this is the first time I've seen 0, so that's why I'm putting the equal sign with it. My last piece is this last one over here. So I have negative x minus x is a negative 2x. Then I have minus minus 1, which is a plus 1. And that section is good when x is smaller than 0. And that's my really the most complex type is this last type, where I have 2 or more inequalities to add or subtract. Okay, how are we? Is this okay? Any questions for me? Okay.